Ladies and gentlemen, prepare to have your minds blown. Nvidia's CES 2025 event has taken the tech world by storm, unveiling jaw-dropping advancements that will redefine AI, gaming, robotics, and supercomputing. From laptops packing the power of desktop GPUs to AI processors that could teach robots to understand our world, this is the future we've all been waiting for. Stick around because this video will dive into each of these revolutionary technologies and show you why Nvidia's innovations are set to change the world as we know it. Let's kick things off with Nvidia's RTX 50 series GPUs for laptops. Yes, you heard that right. Desktop level performance is now crammed into ultra-thin laptops, starting at just $1,299. Thin and powerful. These laptops are thinner than ever, yet deliver performance rivaling the RTX 5090. Perfect for creators, gamers, designers, and students can now handle demanding tasks like 3D rendering or gaming on ultra settings anywhere. Futuristic design. From glowing keyboards to advanced cooling, these laptops scream innovation. Imagine playing your favorite AAA games on ultra settings while sitting at a coffee shop. Mind-blowing, isn't it?
Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 4090 performance at 549. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070.
If you thought laptops were impressive, wait until you hear about Nvidia's exaflop scale computing. Their Blackwell GPUs deliver an insane 1.4 exaflops of AI capability. That's enough to process the entire internet's traffic in real time. Unmatched power, 14 terabytes of memory, and 1.2 petabytes per second bandwidth. Transforming industries. From climate modeling to drug discovery, these GPUs are powering the next wave of breakthroughs. Artistic visualization. These chips don't just process data, they're enabling creative solutions to humanity's toughest problems. Think of the possibilities. Predicting hurricanes faster or accelerating cancer research. That's the power of exaflop computing.
Let's take a look at Blackwell. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. Now, the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible, and this is basically one giant chip. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere.
We would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. If we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. The blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live.
Now let's talk about Nvidia's Cosmos platform. It's an AI dreamland, training machines to understand the physical world using 20 million hours of video. Smarter AI models, from fast response neural networks to ultra-large teacher models, Cosmos is pushing AI to new heights. Dynamic training. These models can evaluate, teach, and even generate realistic physical world simulations. Open source innovation. Cosmos is available to researchers worldwide, fostering collaboration and creativity. And this is the foundation for next-gen robotics, AI development, and beyond. The possibilities are endless.
So, physical AI. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically-based synthetic data. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
The Nvidia Thor processor is here to revolutionize autonomous systems. It's 20 times more powerful than its predecessor, making it the ultimate brain for robots and self-driving cars. Real-time processing, Thor handles enormous sensor data with precision. Versatile applications. From humanoid robots to autonomous vehicles, this chip does it all. Game-changing AI. It's designed for accuracy and reliability, ensuring safe and efficient operations. Thor-powered robots could be assisting in disaster recovery or helping the elderly in just a few years. The future is closer than you think.
Every robotics company will ultimately have to build 3 computers, fundamental computers. One computer, of course, to train the AI. We call it the DGX computer, to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge, and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation. These 3 computers are going to be working interactively. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. The next example, autonomous vehicles. The AV revolution has arrived. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Hang on a second. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars.
With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. Nvidia's AI data factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
We are going to have mountains of training data for autonomous vehicles. I think the next part is robotics. The ChatGPT moment for general robotics is just around the corner. This will be the largest technology industry the world's ever seen.
Robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The Nvidia Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations.
We're going to have mountains of data to train robots with. Nvidia Isaac GR00T. Nvidia Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics.
Finally, we have Project Digits, Nvidia's AI supercomputer that fits on a desk yet delivers unprecedented power. Grace Blackwell chip. This collaborative chip packs massive AI capabilities. Cloud integration, which runs Nvidia's full AI software stack and is accessible as a cloud service. Democratized power, small labs and startups can now afford high-performance computing. Imagine running a cutting-edge AI startup from your home office. That's what Project Digits makes possible.
I have one more thing that I want to show you. Where's DGX-1? DGX-1 revolutionized artificial intelligence. And so I just wish that DGX-1 was smaller. And, imagine, ladies and gentlemen, this is Nvidia's latest AI supercomputer. And it's finally called Project Digits right now. All of Nvidia's software runs on this. DGX Cloud runs on this. This sits, somewhere, and it's wireless or, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and Nvidia's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. Thank you.
NVIDIA's CES 2025 event wasn't just a showcase, it was a glimpse into the future. These innovations will redefine gaming, robotics, AI, and so much more. Whether it's laptops that bring desktop power on the go or supercomputers that process the unimaginable, NVIDIA is shaping the tech landscape of tomorrow. What do you think? Which of these technologies are you most excited about? Let us know in the comments below. And don't forget to hit that like button, subscribe, and ring the bell for more futuristic tech updates. Thanks for watching, and we'll see you in the next video.